Hello everyone, welcome to the Bayer station. My name's Colin Mumford. I provide technical support at Bayer, so if ever you have any queries, questions or want information about our products, I'll be the person most likely you'll speak to on the end of the phone or on the email. To my right is...
And I'm Ruth Mann and I look after the research here at STRI.
Right, today what we'd like to talk to you about is the process of producing a new product for sports turf management. Before we go through that process, I'd just like to ask you if any of you have a rough idea on how much it can potentially cost to produce a new product. It actually can be as much as £300 million. The reason why this is such a vast amount, it's literally a 10-year process to bring a new product to launch, culminating in new products and trials that we have here. We do actually have a new product that's being trialled here at the moment. It's a new active ingredient, it's a new class of chemistry, and it also is a new mode of action for controlling disease, which we'll speak more about in a minute. The benefit of that is you need different active ingredients to be able to rotate the active ingredients that you have so that you're minimising the potential for disease resistance build-up. So what I'd like to do now is just talk you through this storyboard, and then we'll speak a bit more about the trial plots, and ultimately we'll culminate in going to a fighter-back system over there, which is a method for minimising pesticide residues in your washings, so after you've applied a product. From the outset, we look at literally 100,000 molecules to look for specific traits which are required in a product for turf grass management. Those traits are the result of feedback that we have received from turf managers such as yourself. So the feedback that we have received through these feedback forums is traits specific, such as to control a specific disease, whether you want a product that's going to work when the grass plant isn't actively growing, whether it is actively growing, if you want a product that's going to control multiple diseases, specific diseases, and also whether it will perform in various environmental conditions, whether it be hot, cold, wet or dry. And so all feedback like that is taken into consideration when we're screening the molecules. When we go through this screening process and we've finally whittled it down to a manageable size, we then go to the next stage. And that stage is looking at these molecules in ways in which they can be blended, create recipes, formulations that achieve products which ultimately will do the job that you want it to do. This is carried out at two locations. Here is our research centre in Monheim in Germany. We also have a research centre in Clayton in the USA. At Clayton we also have a golf course. So when we're trialling and researching these products, we're not just testing it against grass plants grown in a pot, in a greenhouse or a laboratory. It's actually in real life situations. So the product is subject to the same conditions as would be found in a working golf course, football pitch or any other sports turf environment. So it's subjected to the wear from play, the stresses from actual maintenance, so heights of cut and the like, and also the environmental conditions in terms of rainfall, drought and hot and cold conditions. Once we've gone through that process and we've then arrived at a product which we're confident in, again meeting your criteria, it then goes through the regulatory process. So it will use end user trials such as yourself. We have trials by independent bodies such as the Sports Turf Research Institute, and we need to have all this trials data. We need a massive trials data to be able to submit the information in a dossier to the regulatory authorities for approval. In the case of a broadleaf, a broad spectrum fungicide, we need to be able to test the fungicide against each specific disease that would be claimed on the label. So for instance, it could be red thread, microdochium patch, dollar spot, leaf spot, so on and so forth. Each disease needs to be tested against separately in all manner of conditions, both wet conditions, dry conditions, golf green environments, football stadium environments and the like. Environmental regulation is actually becoming more restrictive. They're becoming more requirements imposed on manufacturers. If I give you an extreme example of regulatory restrictions, in France, has anyone heard of the Labo law? In France, from 2016, in public spaces, it will be illegal to use plant protection products, pesticides, in public spaces from 2016. So those managing public parks and open spaces will no longer have the pesticides as a tool at their disposal. And I say pesticides as a tool because pesticides should always be used as part of an integrated approach to turf management, shouldn't be relied on as a sole means of controlling a disease or other problem, say in the case of weeds, etc. When we've reached that stage and we're carrying out all these trials, end user trials such as yourself, identified through our customer advisory councils and other feedback sessions, we need you as much as to carry out the trials and to feed back any information which may benefit or enable us to further improve the product before it actually is launched. Now, I've said it's a 10-year process and we do have a new product here. The product over here is in the final stages of the regulatory approval stage, and so it will still be about another 2 years before it becomes available. With the regulatory restrictions, we don't actually see that as a real problem. We view it as a positive thing at Bayer because it makes Bayer become more creative, more innovative in the products that it produces. So we surpass the requirements of the regulatory authorities, and we're producing products that have a lower environmental impact, still achieving the high quality product that you would expect and achieving the results of controlling the diseases that you want to treat. Another one of the innovations driven in part from the regulatory restrictions is our stress guard technology, formulation technology. What is stress guard formulation technology then? It was introduced in the UK last year with the launch of Interface, which is our current, our newest fungicide, broad spectrum fungicide. It's been used in a number of products in the States already, and what it is, in the case of Interface, where it's 2 active ingredients, it takes active ingredients in a product and it's formulated with them, and it blends those products in a way that you actually get improved efficacy from those active ingredients. So you get a synergistic effect. In terms of people do ask, well, what is in stress guard formulation technology? As I say, it's not one ingredient, it's a blend of many components. It will include things such as stickers, wetting agents, and pH buffers, to name a few. As I say, they're blended and formulated specifically to those active ingredients within the product to achieve a more efficient, better performing product. One of the asides of the stress guard technology is that it does display improvements in turf grass health as well, in addition to controlling disease. And stress guard technology has been used for a number of years now in our products that we have in the USA. We first introduced it to the UK last year, 2013, in the product Interface, but in the USA an eminent turfgrass researcher, Joe Vargas. Has anyone heard of Joe Vargas? Yeah, we do have a take. Put the camera on that man. We have a taker. He's done some work with stress guard technology, and he's come up with this pithy description. I won't read it all, as you can see it's there, but essentially he's saying that it helps protect the chloroplasts, and the more chloroplasts you have, the greater the plant can photosynthesize. And if the turf grass is photosynthesizing easily, very well, it will lead to a healthier turf grass. And you'll see now, Ruth will explain the trials here. You'll see some of the benefits displayed here on the plots.
Okay, so you want to come around this side, then you'll be able to see the labels on the turf. So when any of the companies come to us looking for trials work, there's one thing we always have to try and make sure we do, and that's produce whatever the problem is that they want to test products against. We're having to try and put in place the problems that they want to try and solve with the products. So part of this was looking at disease. So we'll have to try and create the pathogen, but we also needed to try and create stress to look at the actual stress guard technology within the fungicides. So this area would be the equivalent of a golf tee or Jason close your ears, a poor football pitch. The predominant grass is perennial ryegrass. We've also got quite a lot of annual meadowgrass in it. To be able to produce the disease, which in this case was red thread, we need the grass to grow pretty slowly, and we need to create the right environmental conditions for the disease to come in. This is perfect, but unfortunately we haven't had this all summer. So we have mister systems. So we set up a mister system, we mist it every night, we keep this lovely dew on the grass at all times, just great. And we end up being able to get red thread in. But on top of that, we want to create stress. We also want to have the ryegrass growing as slowly as possible, and we can do that with the growth regulators. Ryegrass loves the growth regulators. But if you go to too high a rate, which is what we've done, annual meadowgrass then struggles, especially in a low fertility situation that this is in. So I'd love to be able to say we can get heat stress and drought stress in Yorkshire, but it isn't that often that we do. So we've gone for a stress that's been a physical form that we've actually created, but it's a good method of doing it. Now, the first thing I will always look for is that we end up with an untreated plot that has got plenty of disease in it and has also got the stress on the annual meadowgrass. And then we're testing everything from it. So looking at it from the company's point of view, the products thereafter, so Chipcro Green, Iprodione, good fungicide, no disease. But you can still see that the annual meadowgrass is not happy, so it's still stressed out. In the corner plot, we've got Dedicate, trifloxystrobin and tebuconazole. Again, good fungicide, no disease, but you've still got stress on the annual meadowgrass. Whereas when we come down to these two end plots, this one has got the interface, Iprodione, trifloxystrobin, just as you'd expect. There's no disease on the plot because it's good fungicides. But when you actually look at the annual meadowgrass, it's not as stressed out and as yellow as it is in the untreated plots. So it is not having as much stress on it, or it's recovering more quickly from the stress that's been imposed by the low fertility and the growth regulators. And then looking at this plot, which again is the test product, which has the stress guard technology in it, there's no disease, so you haven't got any problems with the fungicide active, but you've also got meadowgrass that just isn't as stressed out as a result of the stress guard technology. I will also always have positive controls, and the idea of the positive control is that when you're running disease trials, if we ended up with the test product didn't control the disease, is that because we've been too successful in getting the disease to come into the area, or is it because the test product didn't work? So by having the positive controls, which are fungicides that we know will work against whatever disease we're investigating, there could be Bayer's, there could be other companies, if they work, it's a good trial. So we've got an untreated, plenty of disease. We've also got a product we know will work, no disease. If this product, the test product, works and is as good as the positive controls, great. If it doesn't, we can quite confidently say the test product doesn't work. We will also always replicate things, because it could be that this plot here gets afforded a little bit of protection by the banking. It could be that naturally this corner of our lovely football pitch is a little bit higher in fertility. So we will always have replicates, and the replicate of the interface plot is this one here. And even from where you guys are, you'll be able to see that the meadowgrass just isn't as stressed out in this plot. And the replicate of the test product is this one. And same thing again, no disease, and you can see that the meadowgrass plants aren't distressed out. Now this trial would be a golf tee or local authority football pitch. We're looking at red thread, but there's a plethora of other sports, other surfaces and other diseases. So as well as having this trial running here, we will have trials on our golf greens. We haven't got any golfers, but we do have push-up golf greens supporting a lot of anthracnose. Same trial setup. We're looking at the management with the various different fungicides and the stress guard technology. We also have areas set up specifically for microdogium trials where they're down the bottom of the trials ground, much wetter, much more thatch. We develop the areas so that we get the pathogens. And further on up, we've got some much better football areas where we're looking at leaf spot and management of the leaf spot diseases. Now, with the Sustainable Use Directive that is now law in the UK, all of you guys must be doing integrated pest management. So on top of just using the fungicides, you must be proving that you're also thinking about your mowing, your fertility, irrigation, so that it all comes together. But because we're always looking quite into the future, integrated pest management is here and now. There has to be other things going to happen. So we're also investigating alternatives. And with the companies, Bayer included, we're actually looking at the next generation. So looking at an alternative to synthetic chemistry and being able to manage some of these pathogens without the need for or in combination with the synthetic chemistry.
All right, thank you, Ruth. As Ruth says, an alternative solution to synthetics pesticides is beneficial in two ways. Firstly, it reduces your environmental impact because you're using less pesticide, and secondly, it gives you, as an alternative, it helps in part with that rotation system that you want when you're rotating your active ingredients to minimise disease resistance build-up. What I'd like to talk now about is affects yourselves and affects all manufacturers of hazardous products. Driven by Europe, there's a change in the regulations in terms of the way that the hazard and the risk of a product is reported. So the hazard symbols on all products and the risk phrases on all products is changing. So the orange background with the black skull and crossbones, those symbols, they're changing. The new symbols, and there's a greater number of symbols, they're more specific, as I say, the phrases have changed. As manufacturers, not just Bayer but all manufacturers, we have to introduce those new labels by June 2015. Bayer's actually been proactive and has already started and initiated the process, so potentially if you're using Bayer products towards the end of this year you could start to see the new labels. Don't be alarmed, the product hasn't changed, it's just purely the way in which the risk and the hazard is reported on the label. So it won't affect you. When you do your COSH assessments, your COSH assessment will still be the same for that product. You will have a new safety data sheet because the risk phrase has changed on the safety data sheet. However, we're introducing them virtually straight away, but the distributors, so your suppliers, don't actually have to sell those products with the new labels until June 2017. So dependent on their stock levels, that will probably dictate when you start to see the new labels filtering through to you as end users.
This is all part of the Sustainable Use Directive again, so it's the authorisation regulations in the UK have changed in line with Europe, so that when pesticides are now being authorised, they're authorised by hazard rather than risk. So we always took into account the hazard of using something, but taking into mitigation the actual sensibility of our brains in using it. Whereas now Europe has decided they want to look just at the inherent hazard, as opposed to accepting that some of us are very good at it and some of us may not be.
As I mentioned, we've talked about the process of producing a new product through to launch, the trials here and it being used. Once you've applied a product, you've got your spray tank, you need to wash it out, you need to dispose of those washings. Common practice is to spray the washings onto a practice area or some rough ground. That's, from an environmental standpoint, that's not really good practice because you're applying a pesticide to an area that doesn't require it. So you need to ideally dispose of those washings in a more sustainable and environmentally friendly method. So we have the fighter back system over the back there. If we all walk over there, but en route to walking over to the fighter back system, if you'd like to grab a bag and a pair of socks, we've thought we'd look for something useful to give you this year. So we've got socks for you if you don't mind having Bayer written on your ankle. But if you'd like to grab your bags, then we'll head over to the fighter back system. Okay, so this is the fighter back system. It's a system used for breaking down pesticide residues in your tank washings. So if you're using a knapsack sprayer, you can empty the washings directly into the holding tank here. If you're using a wheeled sprayer system, you can wash it down on the wash down pad here. The washings will collect into the sump. They're then pumped into the holding tank. From the holding tank, as you saw when it was running, the water is pumped through these spray bars. The water then passes through two different mediums. The first medium is straw. Any straw will do, preferably barley straw, as that seems to have greater effect. And the second medium is soil, so soil from your surrounding area. Most soils will be compatible. The exception would be if you've got, sorry, it's just going through a cycle. The exception would be if you've got a clay dominant soil, because that would impede the water flow. So what happens, as the water is pumped through, it gets oxygenated. This highly oxygenated water passes through the medium, and it's that oxygenated water helps the microbial communities to proliferate, to increase in their populations. The microbial communities will break down the pesticide residues. This is a closed circuit, so it's looped round and recirculated. So the water passes through the medium quite a number of times, and so is broken down increasingly by the microbial communities. The way in which the water is removed from the system is that it relies on evaporation. So as the water is sprayed through the spray bars, there will be an element that's lost to the atmosphere through evaporation. And so over time, the water levels will go down as it's lost to the environment. The straw will break down naturally to nothing in essence, and needs to be replaced about once a year. The soil again can remain in situ. This particular system has been running for about 2 years, and the soil hasn't been replaced yet. It's a modular system, so if you're doing frequent spraying, so you've got lots of washings that you need to dispose of, additional units can be added to the system to increase the capacity of it. As I say, it's a biological system, and it's just another way of you reducing your environmental impact by disposing of pesticide residues in this manner, rather than spraying them to areas that don't require spraying. There's currently the system was developed in France. Currently there's about 200 units in use in France on race courses, football pitches and golf courses. And in the UK there's about 4 systems currently in use, including this one. Pesticide residues have been measured here at the STRI. Iprodine washings, so Chipco green washings, have been emptied into it. The measurements have been taken of the presence of iprodine, and then over time it's been re-evaluated and has been shown to reduce quite significantly the presence of ipridion in the water.